Good morning, everybody. Today we are discussing the next topic of the nuclear chemistry, that is isotope as tracers. So we can divide the tracers into two different types. One is radioisotope, which shows the radioactivity. The other one is a non-radiative isotope, but we can detect this isotope by using the mass. So this isotope, due to its radioactivity or differences in mass, can act as a tag or label for tracing the particular element or the compound in the different field. So the general characteristic of the isotope is that it can be easily detected and they can give the measurable signal even when present in a small amount, and it should have the appropriate half-life which must be measurable quantity, and it is used in different field like medicine, agriculture, study of the reaction pathway and the structural elucidation. Now we are moving into the individual radioactive isotope. For the first one is the phosphorus P32. It is used in the agricultural field. So in the agricultural field, radioactive P32 is used for tracing the uptake of the fertilizer by the different part of the plant. So first of all, here we are injecting the fertilizer which contain the radioactive traces of P32, and we will measure the radioactivity of the P32 at different interval of the time. And here we can see that the phosphorus is, we can measure the radioactivity of the P32 at the different part of the plant. Thus we can measure the uptake of the fertilizer in the plant. So this is the most important application in the agricultural field. So second application, radioactive tracers, is used in the industry for detecting the thickness of the coating, layers, papers and metal sheets, rubber sheets, etc. So here we are usually using strontium 90, and which will produce the beta rays, and we can easily measure this beta ray. Thus we can check the thickness of the pipe in the industry. We can use this application for the different field. Either it may be very thin sheets itself or very thin coating itself. We can easily find out by using the tracers. And we can also check the cracks in underground pipe. So this is the very important application. And also we can use the corrosion of this pipe, underground pipe, also in the by using this radioactive isotopes. The next application is that the main drawback of this radioisotope is that it always produces the radioactivity and it will causes the health issues. So that's why we can also use the non-radioactive isotope as tracers. And but it can be, one of the advantages that it does not produce any health issues, and it is very stable and permanent existence in the system, and that is the advantage of the non-radioactive isotopes. But at the same time it has some of the limitation, that is the non-radioactive isotope can be measured by using its mass. So its detector is very costly. That is the disadvantage of the non-radioactive isotopes. And the one of the non-radioactive isotope is the oxygen 18, which is used in the photosynthesis of the plant. Thus we can find out the mechanism of the photosynthesis. Now, the radioactive isotope is also used in the radio diagnosis. And first example is the iodine 131. Iodine 131 is used for detecting diagnosed thyroid disorders. So we are usually the sodium iodide or potassium iodide solution given to the patient, and which contain iodine 131, and we can measure the radioactivity just above the thyroid, And if the the isotope, the iodine is absorbed at the normal rate, or if it is a patient, we can measure the difference in iodine 131. Thus we can compare the uh, normal thyroid and the growth in the thyroid. Okay, so next is the iodine 125, also used for the thyroid gland. It is used to image the thyroid gland. So the third application is the sodium 24. It is used for finding out the blocks in the body. So we can measure the flow of the blocks in the flow of the blood, and we can detect the possible constructions or obstructions in the circulatory system. Okay, so for that we are usually sodium chloride solution is given to the patient, and in which sodium 24 is the radioactive isotope, and it is injected into the vein in an arm or the leg, and we can measure the count of this radioactivity of the sodium 24. Okay, thank you.